let me share. So can you see my screen now? You can see it, okay? So we are going to repeat, continue with our calculus. So let's just open that book first. So what we have done so far, we did up to, okay, so this one here about these derivatives, we did them. So I think you are fine with this one. Use of a derivatives, finding the equation of a tangent. So I think I'm a little bit far, but let me check. Okay, average change is fine. I just want to check because I'm thinking of doing the one with the one I told you about the graphs. This one you did them, you were happy, I was happy the way you answered them. So let's proceed. So we're gonna go to this one, is just the solutions, use of a derivatives. So in a use of a derivative, finding the tangent of, finding the equation of a tangent. So when you find the equation of a tangent, if you read here, find the derivative f prime, work out the derivative at x equals to a, that is I, find for example f prime of a to get the tangent of the gradient of the tangent, and then calculate the y value of a, x into a, there it is f of a. The tangent line is a straight line, okay, they are telling you that we're gonna do that, then they will give you an equation. So for example, in this example here, I'm just gonna demonstrate a little bit with it. So if you have f prime of x, you see f prime of x is 3x squared, you have f squared cubic there, then f prime, then f of 1, f prime of 1, you will see that is 5, then your m is 5, then f of 1 is 7, then the tangent line is y minus 7 equals to 5 in brackets x minus 1. So that's fine. So after that, we're gonna get your equation of a tangent. So now we are going to do it properly. So let's just go straight to the board. We're going to do it in a board. So when we do it, so I'm gonna open my board here with me. So I'm going to start with that example, then we're gonna do more of those examples. So remember, the first thing when we talk about a tangent, so when we talk about a tangent it's a straight line. When we say it's a straight line, you are going to use an equation, y equals to mx plus c. So when we use y equals mx plus c, so if you are given f of x, you will be given f of x. F of x, it can be, for example, let's open that one. F of x, it can be x cubic, it can be, let's use this one, it was x cubic plus 2x plus 4, x cubic plus 2x plus 4. So when we have f of x equals to x cubic, f of x equals to x cubic, is it plus 2x?
2x plus 4.
Is plus 2x plus 4, okay? Alright. plus 4. Let me just write properly. Now I can see that my handwriting today, I'm just starting writing. So it's fine when we have this. So now what we're going to do, we're gonna first differentiate f prime of x. When we differentiate f prime of x, you know, according to the rule that we did, that this 3 will go down. It's going to say 3, it's gonna say 3 x, you subtract by 1, is gonna be 3x. 3 minus 1 is 2, plus this one here, it will go down, it's gonna be 2 times 1, x to the power 0, which is going to be 2. X to the power 0, remember when we put 1 minus 1, is gonna be x to the power 0. X to the power 0 is 1. So we can just say x to the power 0, just to show you, but I'm not supposed to be writing this now because you know. Then this is going to be 3x squared plus 2. So when it says 3x squared plus 2, then we check in our, they will give you a value there, they will give you a value, they will tell you that where point when x equals to 1. We are working at point when x, they say when x equal to what? Equal to 1. Then we're going to find f prime of 1. You see, I substitute this one there in f prime. Our f prime, we find that is 3x squared plus 2. When it's 3x squared, we're going to say 3, we substitute 1 squared plus what? Plus 2. So now when we substitute 1 plus 2, then we're gonna see that this is going to give you 3. 1 squared is going to be 1, then which means you're going to have 2. 3 plus 2, which is going to give us 5. So now when you have this 5, your m, which is gradient, is equals to f prime of 1. You see, at that point when x equals to 1. So now we have a gradient which is equals to what? Which is equal to 5. But we need, then if we want to rewrite this in the form of this equation, we can write it in the tangent line. It will be y equals to 5x plus c. So we don't know c now. When we don't know c, what we're going to do, we know that at x, value of x, we're going to substitute the value of x in the original equation, f of 1. So to find f of 1, we're going to say it was 1 cubic plus 2. You use the original equation. You use this equation to find the other value, so that we can substitute them and find the value of what? And find the value of c. Then you're gonna say 2 in brackets 1. It was 1 squared, plus, is it plus 2? Let me check. Let me check again. Yes, it's plus 4. Plus 4. So now you will see that the answer here is going to give us 1 plus 2 plus 4, which this is going to give us equals to 7. So now we have a point when x equals to 1. In our graph we get what? We get 7. So remember, if we have a cubic graph, I'm not going to draw that graph. I'm just going to show you how cubic graph can be. It's an example. A cubic graph, it can be a graph like this. You see, you will find that when x equals to 1, let's assume this is where x equals to 1, and then, or that's when the tangent touches. You will find that this tangent is touching here. You see, this is a tangent line. Where it touches there, if we are assuming that this point at x equals to 1, we assume that here is going to be minus 7. I'm just giving an example. You see, that's where the point touches. So that's the reason why when we calculate our y value that to use, this 7, we substitute it in what? In the cubic function. So this was just an example. It's not the answer for the questions that we are doing. So now when we have done that, we have found the values of what? The values that we can use, x1 and x and y value coordinates. So now we can come to our equation. We can substitute these values. We can say 7 is equals to 5 in brackets 1, we are substituting this coordinates, plus we want to find the value of what? C, plus C. So when we do that, you will see that we are going to get 7. You take, this is 5, you take it the other side, it's going to be minus 5 equals to C. So our C, you will see that equals to 7 minus 5 is 2. So our tangent equation, it will be y equals to 5x plus 2. Do you see that? Our tangent is going to be y equals to 5x plus 2. Do you have any question?
Can you do another example after this one?
Yes, we're gonna do this one. It was just for demonstration purposes so that you can see. So if you check here, we get the same equation, but now we're going to take, for example, for now we're gonna take some small, we're gonna take some few equations. So I'm gonna need maybe an equation, any equation that we can use for just to get the tangent. So I'm just gonna take any random, I'm just looking for equation without, even if it's not for a tangent, as long as that equation it will ask. Okay, we're going to use this equation. So the equation we are going to use there is going to be, just going to use, let's say is x cubic minus x squared, x cubic, let me just write it down, we have x cubic, okay, it was x cubic, okay, our y, let's assume our y is x cubic, I'm forgetting too much, okay, minus x squared minus 5x minus 5x minus 3 is minus 3. So minus 3. So let's assume that this equation, we are finding a tangent at x equals to, now let's use 2. Let's assume that. So the first thing in this equation, you're going to find your y f prime. This can be also the same as f of x. We are going to find f prime of x. So when we find f prime of x, when you differentiate this, you are going to get 3x squared minus, we are coming to this 2, it's going to be 2x minus 5 for this one. Then you will find your f prime of 2. You see, when x equals to 2, when at 2, at point 2, then we're going to substitute 2 in this equation. It's going to be 2 in brackets squared minus 2 in brackets 2 minus 5, whereby this one is going to be 2 squared is going to be 4. 4 times 2 is 8. 8 minus 4 minus 5. So this is going to be equals to 8 minus 4. We know that is going to give us 4. 4 minus 5 is going to give us minus 1. Then it means that our m, which is gradient, is going to be minus what? Minus 1. So when our m is equals to minus 1, our equation, it can be written as y equals to, for gradient, for this is a equation for tangent. Tangent, it can be written as minus x, because it's minus 1, plus c. So now, plus c. So now we will want to find the value of c, but we know that we have what? At x equals to 2, we're going to substitute this x equals to 2 in this original equation. So when we find f of 2 in the original equation, we're going to find f of 2, then it's going to be equals to 2. Hello?
I think we made a mistake.
Okay, let me check. Just give me 1 minute. Okay, my mouth is running too fast today. No, it's fine. Okay, where did I make mistake?
Yeah, F prime 2, man.
F
We
prime
said 2. Isn't it supposed to be 3?
2. We mean, oh yes, you are right. I made a mistake there. Let me correct it. Thank you for that. To see that, yes. So it's going to be 4 squared. It's going to be what? 4 squared. 2 squared is going to be 4 times 3, which means here we're going to have 12. Ne?
Yeah.
12. That's what is needed in mathematics. When you can see that, because the moment when you do something wrong, that question was wrong because of that 3, that 2 that I used there. So it's going to be 12 minus 4 minus 5. So 12 minus 4 is going to be 7. Is it going to be what? 8, ne?
Yeah.
8. 12 minus 4 is going to be 8. And 8 minus 5 is going to be 3. Yes. Then we're going to have positive 3. So now when we have positive 3, it means that our gradient is going to be 3. When our gradient is going to be 3, then when our gradient is going to be 3, then it means that in our equation here for tangent, we are going to have 3x plus c. So now we will have to find the value of c. In order for us to find the value of c, we are going to substitute these 2 in this equation. So when we substitute that 2 in that equation, we are going to say f of 2 is going to be cubic, and then is it minus, ne? Minus,
yes.
Let me check. Minus x squared, okay, minus 2 again, squared, and then was it minus again?
Yes.
Let me check. Yeah, it's minus 5 in brackets 2, and then the last value is minus 5 again. It's minus, oh sorry, not it's minus 5 minus 3, ne? Yes, minus 3. Minus 3. So if we calculate this, you will see that this is going to be 8. 2 cubic is 8. Minus 4. Minus 10. Minus 3. Which whereby this will give us 8 minus 4 is going to be 4. 4 minus 10 is going to be minus 6. Minus 6 minus 3 is going to be minus 9. So we have these 2 values. So when x equals to 2, our value of for y is 9. So now we're going to substitute these 2 values in this equation to find c. So which means we're going to say minus 9 equals to 3 in brackets 2. 3 in brackets 2. We are substituting these 2 there in x plus c. So when we solve it, it's going to be minus 9 equals to 6 plus c. So when we take this 6 the other side, it's going to be minus 9 minus 6 equals to c. Therefore our c is going to be equals to minus 15. So when we rewrite equation for the tangent, the equation for the tangent is going to be y equal to 3x minus 15. Or you can just say f of x. Another student can write it as f of x. It's still the same thing. Equals to 3x minus what? Minus 15. So do you see how we are doing them? So I'm gonna do let's do a recap. The first thing that we did, we have an equation and we have a point at which the tangent touches. Then we get f, you differentiate. After differentiating, you substitute the value of this point in the f prime. Then you will get your answer there. Then your answer is going to be your what? It's going to be your gradient. It's going to be your gradient. M means gradient. When your f prime of 2 is your gradient, then you can write an equation of your tangent, which is you can use y equals to 3x plus c. You substitute m, because remember this equation is like y equals to mx plus c. Then you substitute m. After substituting m, Then you will go to find the value. This is steps that you can follow. It's just that the way I'm showing you is I'm teaching you in such a way that when you are following these steps, it will help you to not make mistakes. But the other student can use different strategies. Then you will substitute your value of 2 of, after finding this, you will substitute in the original equation, you will substitute the value of x of 2, which is for x, that point. Then when you get this value, you write them in the terms of coordinate. Then you substitute these coordinates in your what, in your equation here, to find the value of c. Then when you substitute them, you will find the value of c. After finding the value of c, which we got negative 15 here, then you substitute back in your original equation, and this is your final answer, and this is the equation of the tangent. Do you get it now? So let me find an equation for you for a tangent, then I will give it to you, then you do it. Let's find an equation for a tangent for you so that we can see how is it going. Give me 1 minute. So in this equation here, I'm gonna give you the equation. Let me just wait for me. So I think you're going to be able to answer it. So today we are not dealing, I'm still going to teach you also how to draw a cubic function. So I'm gonna give you one equation and we will see at which point we can find this. So the question that I want you to do, I'm going to make you share your screen. The equation that I want you to do is f of x equals to x cubic minus 6x squared plus 11x minus 6. So I will say you must do it at point. Let me check which point can I use. Okay, let's say you are finding a tangent equation at point 1 when x equal to 1. So let me make you be a presenter so that I can see what you are doing. So I'm going to make you a presenter now. Oh, did I just mute your mic? Okay. Okay, you can start presenting and go to your board. All right. Oh, you didn't delete for yesterday. Somebody didn't check. Okay, it's fine. Okay, do you remember the equation, right?
Yes.
All right. All right. I'm checking. Let me also observe. Okay, the first step is fine. I'm happy with it. Okay, perfect. I'm loving that.
Can I raise the first part?
Which part? Okay, let me. Okay, you can erase. You want to erase?
The first part.
Okay, let me check first. Okay, the first part. Okay, I confirm that you did it perfect. Then your m equals to 2. Okay, it's fine. Minus 3 is minus 9. Okay, plus, yeah, it's fine. 2x plus c f of. Okay, yeah, you can. I'm fine with that. right. Okay, f of, yes, okay, it's fine. Yes, yes.
So it's fine.
Hello? Yes, it's fine. Yeah, you did it perfect. That's good. So let me give you one more example again. Let's do one more. You don't have to. Okay, it's fine. I'm just gonna tell you what is y of x. Just wait. Let me give you one more. It's gonna be the same. So this one, you see, that is very simple. These equations. Yes, there is nothing hard there. So try when x cubic. Oh, sorry. Just give me wait. Let me check another one. Yeah. Let's do when you have x cubic minus 7x.
Oh my gosh. 7x.
X cubic 7 minus 7x, ne? Minus 7x, and then minus 6. When x equals to 1, still equals to 1, yes. Before you erase, you must tell me so that I can check.
Okay. I'm done with the first part.
Okay, let me check. Okay, the first part, f prime of x is 3x squared minus 7 to the power 0. We know that, okay, f prime of 1. Okay, remember this is minus 7x. What happening when it comes to minus 7x? X to the power 0 equals to 1, eh? When x to the power 0 equals to 1, which means your equation was supposed to say 3x squared minus 7 only. Then after that you say f prime of 1. When you substitute 1, it's going to be 3 in brackets 1 to the power 2 minus 7. Not, it's still this is fine, but the way you have written it, it looks as if you were making a mistake when you say minus 7 in brackets of minus 1 again. You get my point?
Yes,
Yes. You have to, you were supposed to first, before you substitute 1, you show that, okay, x to the power 0 is 1. Then you just write your equation as 3x to the power 3x to the power 2 minus 7. Then after that, you substitute the value of 1. When you substitute the value of 1, then it's going to be 3 in brackets 1 to the power 2 minus 7. Then after that, you're going to have 3 minus 7, which is fine, is you're going to get the gradient of minus 4. Just that the error, the way you have written them mathematically, it makes some error, it contradicts, have some contradictions. So it's fine, let's proceed. Then you will find your y equals to minus 4x plus c is fine. Then you substitute f of 1 in your, you see the mistake that I'm talking about. When you substitute f of 1 here, but you did a is fine when you say f of 1, because now you substitute minus 7 minus 1 there. So that's why I said you don't have to write that in that one for f prime. Then when you did that, everything that you did is perfect. I don't have a problem with it. Then your y equals to 1 minus 7 minus 6, which is fine, and it's fine, okay. And then minus 6, yeah, y equals to 12 is fine. You can continue. You can continue.
Okay.
Alright, let me check. Then after that, you substitute, okay, minus 12 equals to minus 4, okay, it's fine. 1 and c there, minus 12 plus, okay. So when is, if you get minus 12 equals to minus 4 plus c, then when you take it to the other side, it have to change the sign, it have to be plus. So which means your answer was supposed to be 8 there, minus 8. Then you can correct everything, then I check again. Alright, let me check. Okay, y equals to minus, you got minus 4x minus 8 is fine. So now you did it correctly. So let me give you one more. So now at least if you have a question that asks you to find a tangent at that graph, so it does not necessarily mean that it have to be x cubic. Sometimes you can get a question, let's just do this one, y equals to 4x squared y equals to 4x squared. y equals to 4x squared, let's say minus x plus 3 at x equals to 2, when x equals to 2.
I'm done with the first part.
Alright, let me see. F prime, you got it right. For 8x minus 1 is fine. F prime of 2, you substituted there. 16 minus 1 is 50. Yeah, it's fine. Yeah, it's okay. Alright. Okay, so I see. Mm, 4x squared minus, okay, plus that. Okay, I see you have done it perfectly. So You did it correct. So tomorrow we're going to be doing based on the drawing of the graph of cubic, how to draw a cubic graphs. So today I see that you are good with answering how to get the tangent line, and then when you are given a function. So if you need more exercises, just let me know so that I can give you some exercises if you're gonna need them to do more exercises. But if you think you won't need exercises, then you are fine. You can also let me know. Yes. So hello,
I need more exercises.
you need, okay, I'm gonna send you on WhatsApp or more exercises that you can practice. So tomorrow we're going to be doing, you say tomorrow is Friday, ne? The other class.
This Friday.
Yes, we're gonna be drawing about drawing. So on Saturday we're going to have a 2 hours class. On Saturday we have 2 hours class from 10 to 12. So to Friday it's 1 hour, the same way it's happening today. So I'm gonna send you more exercises on this, on using WhatsApp. So I will see you
On Friday.
Alright, yes. So we can end our meeting.
Bye.
Okay, bye. Hello guys. Okay, our class is just ended. So if you need to attend the class, or if you need a lesson, if you are in grade 10, grade 11, grade 12 or university, or you are doing any mathematics, you can WhatsApp me to my number. My number is 07233733640. You can WhatsApp on me. You can WhatsApp me on this number 07233733640. Let me repeat them once more. 07233733640. Then you can schedule for your meeting, for your classes. If you have a daughter or a son, we do our classes online. He or she will be able to see everything that we are doing, the interaction. If you have been watching this live, you have seen how the class is conducted. I check if the student or the learner is understanding what I'm teaching. So there is a time whereby I give an exercises example, a learner do them, and also there is a time whereby I teach a learner and understand how to do something. So if you need your daughter or your son who is in any grade to be helped, feel welcome to join these classes. Thank you. I'm going to stop this live now.